Good afternoon. Welcome to Tech Talk with Steve, episode 15. My name is Steve Cowles, product manager and technical services manager at AEM Test. Today, we're going to be talking about Network Service Assistant and how we're defining Qualification Plus. We're going to talk about how the Network Service Assistant, affectionately known as the NSA, will bridge that gap between certification and qualification. It goes beyond what the typical qualification testers do. But it's not going to be certification. If you need certification, you're going to want to look at Test Pro, and we've done previous episodes on that, and we'll reference that as we move through. So what I'm going to do first, I'm going to go ahead and share my screen here, and I'm going to bring up a quick presentation. And I promise we're not going to do death by PowerPoint. We're just going to go through a couple of quick slides just to give you an idea of what NSA is all about. So Certi-Lite is the defining function of what makes this Qualification Plus, along with all the other functionality. This is the cable test portion, the physical cable test portion. We perform all of the single-ended tests defined in the TIA 1152A standard. You'll see things that you would typically expect to see in a certification tester. So we're doing things like crosstalk and ACRF and insertion loss. You'll see all these typical measurements that you'd expect to find on a certifier, but it's in a qualification tester, what we call Qualification Plus, because we go a little bit further. You can save test reports just like you would with a certifier. You'll use the same PC software to provide PDFs for your customers if you need to. We also do fiber optic loss testing. We do a loopback loss test. We also measure the DC voltage for hybrid powered optical fiber. So if you are installing a hybrid powered fiber to provide power over an electrical pair to a remote device, such as a PoE extender or maybe a camera, for instance, you can actually measure that DC voltage as part of your optical loss test, and we'll demonstrate that here momentarily. PSE detail and PoE load testing. So just like Test Pro, we do the PoE load test. We also do the SNR-based multi-gig link speed test. So up to 10 gig, we can measure SNR under PoE load and under traffic load. So we'll talk about that. Wired network connectivity, we can do network discovery, we can do switch detail, look at VLANs, give you quite a bit of information about the network to which you're connected, and we'll go through that here momentarily as well. And then wireless, by adding an Edimax USB Wi-Fi adapter, you activate the Wi-Fi functionality built in. You can do some of those same network tests that you can do in a wired network. But also, more importantly, you've got a signal strength test. So you can set an auto handoff, roam the facility, and look for dead spots. So a lot of functionality that we're going to demonstrate in this 30 minutes. Qualification Plus testing. This is giving you a kind of a snapshot of basic verification and qualification testers versus the NSA with Qualification Plus versus certification. And you can see that there's quite a lot of things that you get in the NSA compared to most qualification testers. And then the differentiator, the biggest one between certification and the Qualification Plus, are right down here near the bottom. Approved for warranty of cable manufacturers, that you need a certification tester for. So you would want to see Test Pro. And then bidirectional standards compliant cable certification test. So if you're doing a certification test, it needs to be Test Pro. There are a lot of applications for physical cable testing that really don't require certification. There are some small jobs that maybe don't require it, that you would be able to use an NSA for. There's applications such as network managers, people who are doing moves, adds, and changes. They've already had their cable certified by a contractor who installed it, but now they're making some changes to their network, or maybe they're having a problem and they want to troubleshoot. They want to be able to test this cabling and see what's going on with it. And they want to do more than just a basic wire map test or a distance to fall. They need a little bit more information. So that's where NSA comes in. Again, there's all these the parameters that you expect to see on a certifier you're going to find in the NSA. But again, it is a single-ended test, so it is not certification, it's Qualification Plus. We do a single-ended test into a remote terminator that I'm going to show you here in just a moment. If you do need certification, we have had a previous episode similar to this one focused on our certification tester, the Test Pro CV100 Multifunction Cable Certifier. So we talked about the multifunction aspect of our certifier. It's way more than just a certifier. And if you want to take a look at that, go back to episode 10 that we did back in October. You can go to aem-test.com/ttws, and you'll see all of our previous episodes, as well as a schedule of our upcoming episodes. So please check that out if you are looking for certification. So now I'm going to go ahead and minimize this, and we're just going to get right into it. I've got my my NSA right here, and it is connected to my PC, so we can see the display on the PC to make it easier for everybody to see what's going on the screen. So the first thing I'll talk about is, again, what's at the heart of Qualification Plus. It is the Certi-Lite test. So what I'm going to do is I'm going to click on Certi-Lite here. And I've got a cable here I'm going to plug into the top of my unit. And notice that with my adapter here, I am shown which port I should be connecting to run a Certi-Lite test. So it knows that I'm running Certi-Lite. It's going to inform me I need to be plugged into that port. I can see right away I have one issue at least with this cable. There is a short on there even before I plug in my remote. So I'm going to plug in my little remote terminator. The unit comes with remote number 1. There's also a kit available that gives you this tempo probe, a nice carrying case, and remotes 2 through 8 as well. So in this case, we have a wire map issue. So I'm looking at an open and a short. I'm going to click the middle of the wire map. Just like we do on Test Pro, we can find out where that wire map issue is. So you get this instant wire map as soon as you connect. And when we click the middle of the wire map, it will diagnose it. And here we see we're about 2.5 meters from both the short and the open. And I happen to know this cord right here comes out. It's about that length. It wraps around behind my panel here and plugs into this port. And then that other end of that link is the port next to it. And this cord is about 2.5 meters. So I know my issue is right behind that termination there. Likely the same event, and I created the event, so I can tell you it is. But it's, you can see where that is. So you'll know where to go find that. Other wire map issues that you might encounter. You may encounter, across, between 568A, 568B. I'm going to go into another outlet here. And we'll just plug right into that port on the patch panel. This one looks good. I've got remote ID number 1. We could unplug this and we could put one of the other remotes in here. The idea behind the remotes is that you could take the remotes and plug them into network outlets around the building if you're testing by yourself, and then you could be back in the closet with the tester going from port to port on the patch panel. So here I see I'm in remote number 8, and if somebody had not labeled it or mislabeled the wiring, I would know where I'm connected to. That can be very helpful. So I know I'm connected to remote number 8. I'm going to run a quick auto test on here. Now this will be a little longer auto test than our certification tester. Certification tester runs the Cat 6A auto test, including DC resistance on balance, in 6 seconds flat. With a single-ended test, the main unit, which is the NSA here, has got to do a little more work. So we're taking a little bit longer. It's about an 8 to 10 second test. And we see here we've got an issue with crosstalk here. So what I'm going to do is look at my details, and I'm going to scroll down, and I can actually see the crosstalk graph just like I would on a certifier. And I can see that I dropped below that red line, that limit line. I'm going to look at next locator. Since I failed crosstalk, let's look at the next locator. This is a TDR trace that shows us, based on distance, how far away crosstalk events are. I see a crosstalk event that's a huge spike at the very beginning here. And if I click that, it's right out around that 2 meter mark at the end of the patch cord. So it is behind that jack right there. I also see a couple of other spikes here. I've got one halfway down the cable, and that one was actually created by a kink in the cable that was then smoothed out. So you may also see things like this happen if you had somebody crush a cable with a cable tie, for instance. And then there's a bit of a spike at the far end too that looks to be an issue, but the biggest one is this near end. And I happen to know on this cable that the crosstalk issue that we're seeing here is created because I intentionally untwisted the pairs for that termination. So I didn't maintain that pair twist to the point of termination, and it represents itself in crosstalk. And there's also some crosstalk along this cable, And I ran this as a 6A test, but the piece of cable that's behind this particular link is actually 5E. So we're going to see a little more crosstalk along the cable as well. So we'll go ahead and back out of this test. I could save this test if I wanted to. If I wanted to save a failed test to use it for a punch list for somebody to come back behind me and fix it and then retest, I could do that. Now I'm going to plug into another link and we'll just run a quick test here, and we should get a pass on this one if I've done my job properly. And we'll see that we've got a good connection here. So this one passed. Again, I can see details, including at the very top of this list, we have the network compliance list. So you can see the speeds that you can expect to run over this based on this 6A Certi-Lite test. And it can run all the way up to 10 gig. And we can just save this test. Other functions that you've got built into this, and again, we're talking multifunction here. It's not just being able to run a physical cable test, but in the expert tools section, we've got things like a tone generator. So if you got that kit with the multiple remotes 2 through 8 plus the tempo probe, you'll have a probe that you can use. It'll also work with any RF type probe. So as long as you've got an RF probe, you can use this tone generator function. You've got a high speed and a low speed warble, and I'm just going to go ahead and send tone. I'm going to turn on my tempo probe here, and this is the tempo 200 FP filter probe. And what we're going to be looking for is a tone coming out of here if we've sent the tone properly. There we go. And we've got a little bit of AC noise here, so we can, you can hear that buzz. We've got AC voltage interfering with that tone. If I click this button one more time, note how now I can really hear that tone. So the AC voltage in the area, that harmonic from the AC voltage was interfering with it. Additionally, there's an LED that's on the probe itself, and that LED, as it gets stronger and stronger to the signal, you'll see the LED will light up more. So the closer you are to the tone, the stronger that tone is, the more that lights up. So that's helpful in a noisy environment, but otherwise, there's another application for that little LED, and it'll be red when you're in non-filtered mode, green when you're in filtered mode. But if you're tracing a wire, typically you're going to get bleed over between two wires. It almost always happens when you're sending tone. You'll get bleed over on more than one wire, and if you're toning in a patch panel, you might hear tone on more than one jack. So how do you know which one is the correct one that you're trying to trace? You adjust that gain knob. Some people call it a volume knob, but it's a gain adjustment. And what happens at some point, you'll start turning it down a little bit at a time, go back and forth between the 2 or 3 or 4 ports that are actually exhibiting tone. And at one point, you may still hear tone on more than one port, but the LED will only fire up on the one that actually has the tone on it. So that's how you use that to discern which wire you're actually on if you have a bleed over tone situation. There's also a learn NVP and a length test in here. So these will allow you learn NVP. NVP is nominal velocity of propagation, essentially the speed limit of the cable. It's an important parameter related to the length of the cable. And if you have the incorrect NVP when you're doing a test, it will not give you the correct length measurement. So learn NVP will allow you to take a known length of cable and connect the unit to it and learn what the NVP value is. The opposite of that is the length test. If you already know the NVP, you can do a length test on an unknown length of cable just by putting in the NVP value, and you'll know how much cable you have left. So now we'll go back. I'm going to just leave that test adapter that's in there, the AD NSA adapter, and I'm going to switch over to PoE mode here. So I'm going to change ports on my unit, and what I'm going to do is I've got a link here I'm going to plug into. I've got a PoE injector coming off of this green cable. I'm going to plug that into the other end of the link. And on the other side of the PoE injector, I've got a switch. So here we can see that we've got some PoE. We can choose what we want to look at. Is it 90 watt, 30 watt, 15 watt, UPoE 60 watt? So you choose the one you want. I'm going to leave it at 90. This injector is capable of 90 watts. This is a useful tool if you have a situation where, let's say somebody's got a problem with a PoE device. The power device is malfunctioning and the finger pointing starts. The power device manufacturer says they make the best product in the world. It never fails. They're pointing at the cable, or they're pointing at the installer. The switch manufacturer has the best switch in the world, or the injector manufacturer is the best one in the world. It never fails. It's always perfect. A lot of variables come into play, and you need to help sort it out. So what you do is you're going to take this, you're going to disconnect that power device, connect that cable that goes into the power device into the top of your NSA. You're going to look at the PoE. Sure enough, you're looking at it, and what you want to do is put a load test. This initial test tells you some things. First off, if you don't see a PSE, that's a problem. You're not even getting any power. But assuming you see a PSE, you see what looks like good voltage and the PSE type, you've got PoE on all 4 pairs like I do here, you're showing allocated power of 71.3 watts, which is the theoretical maximum over 100 meters of good cable. And that is what the switch is advertising it can give us. It's not what we're really getting. We don't know what we're really getting until we actually demand that power. We need to put a load on. That lightning bolt is our load button. We demand the load from the switch by clicking that lightning bolt. And here we see we're getting 68.96 watts. Not too bad. It's not the 71.3 that we would expect over a perfect cable, but it might be workable. So maybe you see something here where maybe it's not 68 to 71 or in that range. Maybe you're seeing something along the lines of 25 watts or something way lower. Then you know you have a problem. You're going to go back to the switch, connect to the switch port, and you'll just hit refresh right here. And that refresh will actually give you that updated power measurement. So at the switch, you should probably get a much higher number than the 71.3 because you don't have much cable, and the cable adds resistance and it reduces that power. So if you're plugged directly into the switch, you should get a very high number, much higher than the 71.3. If you're seeing a low power output on the switch, at the switch, you know you've got an issue there. I've actually seen situations where somebody spent $100 on a 12-port 90-watt switch and expected to get 90 watts per port. They were okay when they plugged one device in, but as soon as they started plugging a couple more devices in, things stopped working. So a lot can have to do with the switch. It could be how the switch port is provisioned. Another thing that's often overlooked is patch cords. You want to make sure you test through the patch cord that they're using, because that may be a factor as well. If they put a lower grade patch cord or something with some high resistance in it. So you can do those kind of tests as well to help you troubleshoot that PoE. Beyond that, now we've got the MultiGig SNR test here that we talked about. So what this does is it's going to put traffic on the line. It's going to demand the PoE load at the same time, and it's going to measure signal to noise ratio. So SNR, signal to noise ratio, it basically looks at that strength of what's traveling on the wire versus what is interfering with that. So the noise external to that that's interfering with it. So it's actually a good look at real world impact of alien crosstalk or noise interference. So you can run this test, and what we're going to do first, I'm going to go into my test setup and I'm going to look at the test limit. We can test everything from 100 meg up to 10 gig here. We're going to show connection at 100 meg and 1 gig, and then we'll do the SNR testing at the higher multi-gig speeds. I have deselected the 10 gig because I know that the switch I've got here actually doesn't really give me a good 10 gig connection. So I'm going to just do this up to 5 gig. The default is the IEEE default SNR limit of 0. And that's at the point where essentially your noise and your signal are becoming about the same level. So if it drops down close to 0, you know you have a problem. So we're going to go ahead and run a quick test on this, and we're going to watch this test as it progresses. One thing about being able to select all these different speeds. So you may not have 10 gig, you may not have 5 gig, maybe you don't have 2.5, maybe you're only testing one of those. That will speed up the test. 2.5 and 5 are in there, and a lot of people might think, well, if it passes 10, it's going to pass 2.5 and 5, right? Why do I need to run the other tests if it'll pass a 10? The answer is that a lot of your wireless access point links are going to if they don't already, in the near future, you're going to be running 2.5 or 5 gig to these wireless access points. So you need to test at those rates. So we've gone through the 100 meg and the 1 gig here. We did the 2.5. We're up to 5 now, and this will be done in just a couple of seconds here, and we'll see a test result that's going to show us this passed. We can see 5 gig, we had an SNR 6.3, which is pretty decent, and we have a 10.1 at 2.5. So as long as your rule of thumb, 3 dB is a good number if you want to look at that as your rule of thumb. But every network's going to be a little different. You might have one that works great even if it's below 3 dB, but that's a good rule of thumb. If one of these was problematic, I can look at it by pair, and I can see by pair what my SNR is. I can see the worst case. In this case, it's 3 and 6. We also get our connection information for 1 gig, 100 meg, and then we've got PoE here, and we see our PoE wattage, and we can save this just like we would the physical cable test, the Certi-Lite test. So this gives us more information that we can provide for the customer, or if we're doing our own network maintenance, records of our links that we would use ourselves. So other functionality you've got built in here, the network test and cloud functionality. I'm going to just go ahead and plug directly into one of my local switches here for my home network, and we'll go ahead and connect up. And I can see here, I can go into network tests, and what we're going to find in network tests, we do some discovery. So we're going to see devices on the network. We're going to see those by IP and MAC address. We can get information about the network itself. So I can click on this icon of the NSA, and it's going to pull up some details about my network. It's going to show me what my IP address is, my gateway, my DNS, shows me I've got a gig full duplex connection. I can click this switch detail button in the lower right, and I can run a quick test into my switch and get information about the switch. So you may have a situation where maybe a user is having a problem reaching a resource on the network, or maybe they can't get to the internet. So you'll connect where that user is connected to the network and run a test to see what you can see. You find out, okay, maybe they're on the wrong switch. Maybe they're not supposed to be on Whopper Cheyenne Mountain. Maybe they're supposed to be on a different switch. Maybe they're on the wrong port. We see we're on port 7 here, and that port is on VLAN 1. Maybe they're not supposed to be on VLAN 1. Maybe they're supposed to be on VLAN 2. So maybe you need to reprovision the port. Maybe you need to move them to a different port that's on the proper VLAN, or a different switch even. So this gives you some good information to help troubleshoot in those cases. Also shows us the port capabilities and gives us IP and MAC address information, so we can get all that detail about the switch. And this will work with LLDP or CDP, or as you can see, I've run mine with both because my switch supports both, and I'm running both on the switch. You also have the capability to set this IP address as a static IP. If you're on a secure network that won't let you use a piece of test equipment with DHCP, you can do a static IP, so you're able to actually do the testing on the network. Things like ping and traceroute, we've got those in here as well. So you can do a ping to Google, for instance, and maybe you are seeing a little bit of a slowdown. You can do a traceroute to find out if the slowdown is happening in one of the hops in your own internal network, or is it out beyond your network. Again, the switch detail button that we used already is here. VLAN discovery can be used on a trunk port on a switch, and it will allow you to see the percentage of frames discovered on the various VLANs, but that does require connecting to a trunk port. You do have traffic generator function built in here, so we can generate traffic. Also TCP connect. So if you've got a resource that uses a particular TCP port, you can go ahead and connect, and then you can do a response test on that TCP connection to make sure that you don't have excessive latency there. Beyond these, there is the Wi-Fi functionality here. So we've got the ability to go ahead and plug in a Etamax USB Wi-Fi adapter. I've got one in the side here. I'm going to disconnect my hardwired Ethernet here, and I'm going to go in and turn on my Wi-Fi. And with Wi-Fi, we can do some of those same network tests with the exception of switch detail and VLAN. And this is connecting to the wrong network. I'm going to choose a different network here. It's trying to connect to my cell phone. Let's go in here There we go. We'll choose a better network. So we'll connect to this network. Once we've connected, we can select the handoff option. So we can go in here and we can specify the dBm limit, so that signal strength for the Wi-Fi, where we want it to hand off. So in this case, if it drops below negative 67 dBm, I'll disconnect and try to connect to a stronger access point. And you can see here, we can see the surrounding SSIDs and their associated signal strength. If I go into my signal strength tool, I can roam my facility with this and look for spots where when I do that handoff, maybe the handoff doesn't happen. It disconnects and it can't reconnect. And that tells me I've got a dead zone. So I know I'm going really fast here, but we've got a lot to cover because this is a multifunction tester and it does a lot of different things. So what I'm going to do now, I'm just going to remove this adapter. These are hot swappable. And I'm going to go ahead and connect my fiber adapter. So we may run a couple minutes over today, but I definitely want to make sure that you see this. So it's very easy to switch. Now I've already got my reference cable connected from my transmit to my receive here. We are doing a loopback test with this. So in this case, we've got loopback. You'll also notice I've got another little adapter coming out of here, and this is for testing the hybrid powered fiber that we mentioned. So what I'm going to do is I'm going to, I've got a piece of hybrid powered fiber, and I'm going to connect to my conductors, my electrical conductors that are coming from that hybrid powered fiber. So we'll get that in place. And then we're going to, we'll connect to a piece of fiber here, this hybrid fiber that has a loopback adapter, similar to the one I've got right here, just a little loopback adapter. So the fiber kit that you would get for these will include a loopback adapter for the remote end. And you can see here, I got a live wire map, I'm connected. It is a loopback connection. And all we would need to do a set reference, we would go into our expert tools and perform that set reference once we've warmed up for 5 minutes. Now, some of the other functions you've got in set reference, we have a fiber inspection scope that you can plug into the USB port on the side so you can check your connectors before you connect to anything. You would, again, you inspect, clean if necessary, and inspect again is the rule. VFL built in, so if I turn on my VFL, I've got a 2.5 millimeter universal port right here, the VFL port, so we can actually troubleshoot for a broken fiber at one end or the other. Other things in expert tools, you've got light source and power meter mode in here. So with light source and power meter mode, you can actually use each of these ports as a standalone light source or a standalone power meter. But what we'll be doing is AutoTest. So I'm going to do the set reference, and even though we haven't warmed up for 5 minutes, I'm going to go ahead and run this anyway. It will give me a warning. I'm just going to go ahead and run the set reference anyway, in the interest of time. And while this is setting reference, we see here we've got a good power measurement here. Set reference was successful. We're ready to go ahead and test. Now I'm going to hook up to my fiber under test, and we'll go ahead and run a quick test on this. So I'm going to unplug from here, and we're going to connect now. These I know are very clean, so I'm not too worried. Your normal procedure in the field is you're going to add your second reference cord and then run a quick test of your reference cords to make sure they're within tolerance so that you don't have a lossy reference cord. I'm just mentioning that because I'm, in the interest of time, I've got to skip over that. So what I'm going to do here is I'm going to connect my cords to the fiber under test, and the other cord goes back here on our receive port, and we get our wire map again. And now what I'm going to do is I'm going to add power so we can show you the hybrid powered fiber. We're going to add power to our hybrid fiber here, and we'll put that power on the line here, and now we can see 56 volts on here. I'm going to go ahead and run my auto test, and in about 4 seconds we'll get our test back. And this voltage is part of our auto test. So we're not just testing the optical loss, we're also showing you that voltage for that hybrid powered fiber. We know that we're getting the voltage from that far end. If you need to test the resistance, you can do that with a certification tester, the Test Pro. That will measure resistance on that copper pair. So we see our length, our delay. We can look at loss on the fiber. We can look at our network limits to show us what we can run over this fiber, and we save this test just like any other test. And then once those tests are saved, we can use our PC software, Test Data Pro, to manage that. We can use Test Data Pro to look at more details in tests, so you can see plots and graphs of everything that's on there. You can see your PDF reports, just like the one I've got here. This is a Certi-Lite test, and you could recognize it instantly because it has no data on the remote end. It is a single-ended test, and it is Certi-Lite. So it is a Certi-Lite Cat 6A channel, not certification. So that shows us our test results. So you can manage all that in the PC software as well. And I see we're really close to the end here. So I'm going to go ahead and switch back to the camera here, Jacqueline, and we'll see if we've got some questions. I'm sure there's a few in there. We'll try to grab these and answer a few. It looks like we've got some people from Dubai here. Let's see. Scrolling through the questions. Looks like we had a few people with some technical difficulties. Got a couple of hellos. Don't see any questions. Jacqueline, do you have any questions that maybe popped up elsewhere? So I don't see any. One of the common questions we get is about those patch cords. So I mentioned the patch cords. Resistance is a problem when it comes to PoE. So resistance measurement's important. We do loop resistance measurement in our Certi-Lite test, as well as the DC resistance unbalance pair-to-pair. So we give you both of those in the Certi-Lite test. So it helps you when you're trying to make sure your cable's ready for that PoE as well. So without any questions, I think we're right at the end of the hour. Again, everybody, we really appreciate your time today, and we're going to have another episode coming up in 2 weeks. We'll have a special guest. Chuck Bowser, RCDD Tech, is going to be joining us, and we're going to be discussing manufacturer warranties and why they're so important. So be sure to tune in on December 21st, our next episode, 2 weeks from today. Thank you very much, everyone, and have a fantastic day.